Welcome to Ask and Learn.
So in this problem, we have a car that has a spring as a bumper. And we want to find K, the stiffness of the spring, when its maximum deflection is set to only 0.2 meters and the velocity of the car is 4 meters per second before it hits a wall. We're also given the mass of this car, which is 5,000 kilograms, and the force due to the spring is given as K, the stiffness of the spring, times S squared. And just looking at this equation, we know that the force will vary depending on what the value of S is. So since we're dealing with forces and distance, we know that we're dealing with work, because work is force times distance. And we're given velocity, so we can use kinetic energy, because kinetic energy deals with movement. So we can use the work energy principle, which is given as the initial kinetic energy plus the work being done by the forces is equal to final kinetic energy. Well, just thinking about this problem, we can say that the final kinetic energy will be 0, because the velocity will be 0 once it hits the wall. So now we're just left with the initial kinetic energy, 1/2 m v1 squared, plus the work being done by the forces, and this is equal to 0. We'll call this equation 1. So now let's look at work. So work is found by calculating the forces, but here the force isn't constant. It actually varies, again, depending on the distance. So we have to take an integral of this force dot ds, and the bounds are from 0 to that maximum deflection, 0.2. So plugging in F, we have K S squared ds. Now, because this work is actually done by the spring, it's in the opposite direction of the motion of the car. Car is going to the right, but the spring will force the car to stop, so its force will be going in the opposite direction, so the work is in the opposite direction, so this is actually a negative. So then taking the integral, we have minus K S cubed divided by 3, and the bounds from 0 to 0.2. So when you plug in 0, you get out 0. When you plug in 0.2, you get minus 0.0026 times K. And now we can plug this back in to our equation 1. So we still have the kinetic energy, initial kinetic energy, 1/2 m v1 squared minus this work, 0.0026 K equals to 0. So you can move the work to the other side. So we have 1/2 m v1 squared is equal to 0.0026 K. So we're really looking for K here. So plugging in our numbers and dividing by 0.0026 to both sides, we have K is equal to 1/2, and then M is 5,000 times the velocity, and here it's 4 squared, divided by the 0.0026. So K, the stiffness of this spring, is 15.4 times 10 to the 6 newtons per meter squared.